Thank you. So this schedule, you can get to it from the, it's pinned on the FastAI version 2 library channel of the Slack group. It's pinned, it's one of the ones that are pinned to the top. From this, you can get to all the videos, you can get to the schedule, well, this is the schedule, and it also has the Zoom meeting link that we'll use every week. So, so the idea is, well, let me wait. Yeah, I guess it's time to start. We have like about, what, 16, 18 people here already. That's good. Yeah, I'm excited about this. So we've got, there are 10 videos that Jeremy made back in September, I think, starting in September of 2019, when they started making the version 2 library public. And the videos, so the idea for this study group is that we want to progress through this at the rate of 1 video per week. But remember that these are Jeremy videos, so that means that there's going to be a lot to do to keep up with it. You know, you have to watch the video, but you'll have to watch it maybe a couple times, and you'll have to follow up on a lot of things by trying the notebooks that he's referring to. And hopefully we'll guide everyone through that process, and I'm sure that there are those among us who can actually who actually have a lot of knowledge to share, that they might have already been through these notebooks and know something about the or have already used the version 2 library. One caution that that Srinivas mentioned, he's one of our members. He's taken a look at these videos, and he says that the version 2 library has changed somewhat since these videos were made, so we'll have to be cautious about that. We'll try to make sure that we get the latest on version 2 library. So these are there are 10 videos, and then this is the schedule that I've laid out for this. Basically 1 video per week starting next week, and there will be a July 4th holiday. We'll take a break, and we should be done by the 3rd week of August, and then we'll decide what we want to do from there. Let me see. The plan for today is that Srinivas is going to walk us through. He put together some slides about the videos, and he's sort of going to walk us through those slides. What we'll find out is that the version 2 library is written at a higher level of Python than many of us are used to. And so there's a lot of new concepts that one has to learn, things that you look at them in the code and you say, what's that? I haven't seen that before. Well, hopefully the idea is for us, we will try to explain all of these new concepts, like decorators, and there are various ways that you can use classes and functions in ways that we haven't been used to, and they take full advantage of that in the library. So it's a very high level of Python coding, but we will learn all of these things. We'll come up from our current level of Python coding to be at the level of the people who wrote the library. That's the hope as we go through this. So one of the things we're going to learn from going through the version 2 library is some software engineering skills that'll be very important in being able to understand and also being able to use the library. So I see we have like 19 people here. I wonder if anyone has anything they want to say. Just introduce yourself or say hello. What you're hoping to get out of this, out of this study group.
Hi Joseph, this is Anand here. One of my aims with this course is to obviously get better with my coding, as you're saying, by understanding the depth and the expertise of the FastAI library coders, Jeremy, Sylvain. And using that, I want to be able to customize from other, like, for example, like being able to import native models from PyTorch into FastAI, and then be able to use FastAI goodies like all of the different discriminative learning rates and all of the other callbacks and things that we get within the libraries. So that is why I'm interested in this study group, is to be able to have that flexibility.
That's super. Yeah, I want to spill the beans right up front. I am not an expert on the version 2 library, and I organized this class so that I can learn it. So that tells you something. If you want to turn around and desert us, you're welcome to. If you think that we're being led by experts, well, maybe we're not. But I think we have a lot of talent within our community and among the people that signed up for this class. And I think that it's going to be a collective learning exercise. We're going to learn from each other. So that's how it's meant to be. And Anand, well, you had mentioned something. You put up a link that said this is a good place to start for general orientation to the FastAI library. So I would invite you to, while we're waiting for Srinivas, I would invite you to walk us through that if you
I'm here, Joseph.
Oh, he's there. Okay.
Yeah.
So hi, Srinivas. So I'd like to, so Anand, I'll have you, if you don't mind presenting that, I'll have you do that after Srinivas. Would that be okay?
Yeah, that should be good. Yeah.
Okay, great. Thank you. Okay, so I'd like to continue before I turn this over to Srinivas. I'd like to find out more about you and anybody that wants to introduce themselves and say what their purpose is in joining this course. Welcome to take the mic. Turn yourself on.
Hi, can you hear me?
Yes.
Oh, wonderful. My name's Ellie, I'm from Germany, and I'm mostly looking forward to getting started with the FastAI library because I tried transitioning like a few years back, or like 1 or 1.5 years back, and went back to TensorFlow because I just didn't put in enough work. And I would just use this opportunity to get started together and just use the group to stick with it.
That's excellent. So hopefully we'll have some, after we get through these videos, we might want to even continue. We might have some ideas for how we might want to continue to develop our expertise with the library. But I think that's a great goal. I think all of us share that goal. So thank you for that. Anyone else, please speak up. Yeah, so you know, everyone here is expected to have some basic skill in Python. The FastAI course always says that the prerequisite is that you've been programming for a year or so. So we're assuming that everybody has that, but that doesn't mean that you're really expert in Python, because there's a lot of subtleties in Python that we're all finding out about. And as I found out when I started to look at some of these videos, Sylvain and Jeremy are operating Python at a very high level, and we want to learn how they do that, and we want to learn what tools they're using and how we can operate Python at a higher level. But mainly, we want to learn to understand this library so that we can make the best possible use of FastAI, because it is one of the best ways to build models and do things in deep learning. Okay, well, I'm excited to see everyone here. Looks like we have, 21 people. Are there anyone else that wants to speak up? Don't be shy. Let me know, let us hear from you. Introduce yourself. Okay, that's fine. So I'll turn it over to Srinivas. Do you want to just take over the screen and share your notes?
Yes. So can you hear me?
Yes.
Okay, let me go to screen sharing and then you can tell me whether you can see my screen.
Yes.
Okay, so I just went through most of the videos, as Joseph was saying, really quickly to get myself oriented. And I found out quite a few things. So I spoke to Joseph and he graciously agreed to allow me to talk a little bit in the beginning of what I've found and what some of the things that I realized as I went through. So right off the bat, let's get to at least what I found going through these set of 10 videos of the walkthroughs. What's the benefit or what we hope to gain by going through and watching them and kind of understanding. As a few people, Joseph and Anand mentioned, I think the first thing is it enables you to understand the working of the FastAI 2 library. Most importantly, I think even more than enhancing, which is of course a very important reason, it also allows you to debug when things go wrong, even with, for example, while using it with the first set of notebooks that people who have gone through the first part 1 of the course have already done so. But if you make any changes in it and if you want to play with the notebook and suddenly it spits up on you, you really can figure out what's going wrong and debug. There are several concepts that I used in constructing the library, which enables you to extend the library in ways and customize it. And we'll dive into, as Jeremy goes into the videos, we'll dive into the implementation of the library as well. And the desire of all of us obviously is to make use of the library, to customize it. In fact, there were a couple of questions early on that people had posted on the forums or Slack channel about, hey, I'm doing this or that, and how do I do that? And there was frankly deathly silence on the Slack because not too many people had used the library extensively at that time. And so customization or modifications were not simple questions to answer. Hopefully, by the end of it, most of us would be able to kind of respond, even if there are significant ways and different ways in which you can stretch it. The other collateral benefits you get from really going through the library that I found is it significantly improved at least my understanding of Python and the way it works and the way it can be customized to do a whole variety of things. I'm sure there are, of the 20 people watching, there are a lot of probably expert Python programmers, but I'm not one of them. And it significantly did improve my capabilities in programming Python. And a little bit of changes in PyTorch, and therefore it does help you to gain a little better understanding of what are the limitations of PyTorch and how PyTorch is similar, and obviously FastAI is built on top of it, so you can kind of understand how to customize PyTorch itself or how to change its behavior, if you will, much like as with Python. So by the end of the course, hopefully you can go from, and as Joseph explained, even I am not an expert on the library. There are people probably on the call who have even used the library. I know more than I have. But so what is this Max Planck level versus the chauffeur level thing that I'm referring to? So I'll indulge you guys in a little bit of an apocryphal story, but I think it illustrates nicely the levels of understanding that you can have on any kind of a concept or something like the library. So the story is that Max Planck, who is actually a theoretical physicist, and he won the Nobel Prize, if I recall correctly, in 1918. So apparently after he won the Nobel Prize, he used to go around different towns in Germany and kind of give a lecture on quantum physics and the theory of quanta, which is what he came up with. And a chauffeur used to drive him around to the various venues and listen to his lecture. And by the 10th or the 12th time, the chauffeur was like, hey, you know what, Max, I can give these lectures. It looks like I've been listening to you give the same lectures all the time. So I think to the next place we go where they don't recognize you, let me step in and give the lecture. And Max Planck thought that, hey, great idea. So he kind of let his chauffeur get on the stage and give the lecture. And to his amazement, the chauffeur he had just about memorized the lecture and gave a lecture on quantum physics perfectly. But At the end of the lecture, this professor from the local place stands up and puts his hands up and asks this really ghastly question, diving into all kinds of depth about what the chauffeur had covered. And without skipping a beat, the chauffeur says, you know, I thought this was like a very advanced place of research that I'm giving this talk at. But in order to illustrate what a basic question this is, and remember Max Planck was acting as his chauffeur at this lecture, he said, I'm even going to let my chauffeur answer this question. And pointed to Max Planck, who promptly gave a great answer in detail. So, but you know, jokes aside, I think the point is that you can have the chauffeur level understanding of the subject, which is where my understanding of the library too is at this point. And hopefully by the end, as we all go through, as Joseph said, we can get to the Max Planck or Jeremy level of understanding of the FastAI 2 library. So that's my dad joke for the day. Okay, moving on, the FastAI 2 library, if you look at the overall library code, and it's all available, as Gautam has pointed out in previous lectures, on GitHub, I would say from my looking at it, you can classify it. I mean, there are 10 different ways you can do this, but for our understanding, simplification, there's a significant part of the library which deals with data. And what it does and what the code does is it helps to prepare the data and get it ready for use by the various models. And the 4 types of data that essentially the library at this stage deals with are images, text, tabular data, and then the collab or collaborative filtering type of data. And then there's a whole section of the FastAI library that deals with models that have to do with customization of the models. There are things like ResNets, but built in the specific way with all of the different suggestions and or inputs that or enhancements that modern papers or more recent papers that Jeremy implements and factors into the models. There are things like dynamic and so on. Sorry, I believe I've been muted. Can you still hear me?
Yes.
Oh, okay. And then there's a whole section of the library which also has to do with learning and optimization. This has to do with all of these gradient descent, the hooks that are needed to latch on to the various outputs of the activations, the callbacks which are necessary for the extreme level of customization that FastAI 2 library allows you to do with your different stages of the optimizer. So those are the 3 major sections, if you will. And what I wanted to point out is most of the 10 lectures here that we'll go through, most of the 10 on the videos, essentially are dealing with the data part. That is, how is the library structured in order to be able to take the data that is available from a variety of sources, including from Kaggle competitions and from sources on the web for various functions like segmentation, classification, and so on, and convert it such that we can use it readily with the models that we build for deep learning. Very few, if none, deal with learning and optimization. So if you're really interested in learning and optimization, which is the portion of the library that talks or deals with hooks, callbacks, those portions, the reason Jeremy didn't cover them as much in these walkthroughs is because he went through them fairly in detail as part of the version 3 part 2 of the FastAI course. So to Joseph's point, maybe if we get through all these 10 lectures and if people are still interested, one of the things that we could do, since that's a key significant part of the library, is also go back to the version 3 part 2 and kind of go through that Obviously, there are significant changes in FastAI 2 compared to what Jeremy is talking about in that section of the course, but that's the case even for the current walkthroughs. So what I wanted to do in at least the next couple of slides is not, and again repeat, not go through the details as much as to expose you to some ideas which are foundational to the data portion and essentially therefore to all of the walkthroughs or walkthrough videos that you will watch. And as I mentioned previously, it's fundamentally related to the data part of the library, not so much to the optimizers or to the models. So what Jeremy has done with the FastAI 2 library, the version 2 as opposed to version 1 is, if for those of you who are somewhat familiar with the library, have used it or have gone through the first part of the course, or previous versions of the course, I should say, transformation in previous versions and prior to FastAI 2 was just something that you did to, for example, resize the image or flip it upside down or flip it sideways. So it was mainly augmenting the data in order to be able to either use it or in order to augment the data for testing purposes. In FastAI version 2, what Jeremy has done, and I think especially as Joseph takes us through the hands-on ML course as well, you'll find he's kind of inspired by even scikit-learn library. He's extended the concept of transforms to almost like a transformation system that's built into the FastAI 2 version library. And what does the transformation system look like? Well, that's what it'll take 10 lectures to go through, or at least I think 8, 9, and 10 are somewhat different, but at least 7 to 9 lectures to go through what the transformation system is and how it all comes together. But I'd like to just give you the gist of the idea. The gist of the idea is that he's made transforms a reversible function. Basically, it's a reverse, it's a class that has some methods. And those methods take the input data that you get, like an image or like text, and then converts that into things that gets us closer to the modeling with the data. So that's a lot of words as to what do you really mean, Srinivas, when you say gets us closer to modeling with the data. We'll learn more about that in the next couple of slides and even as we go through the walkthroughs, but ultimately keep in mind that what you give the model eventually is just a set of tensors. No matter what, whether it is text or images or collaborative filtering, ultimately what you provide to the model is a set of bunch of tensors. But with the help of transforms, what Jeremy has tried to do is preserve the high-level semantics of what you already know about the data, even as you go further in depth and get closer to tensors that you eventually provide to the model. So what that says is, hey, when I give you the data and when I start on the data, FastAI library understands or knows whether the data is an image or a text or collaborative filtering or a table from pandas. Therefore, eventually, when I still get to a bunch of tensors, whatever dimensions they are, it would be great if I can still somehow know that this is an image and therefore I can flip it, I can show it, and so on, rather than somehow having to rediscover what the tensors actually are, or have no idea of what the tensors actually are, because they are just a bunch of tensors. So he's introduced this transformation system, which allows you to do something like what I just described. And that capability and how it's built into the FastAI version 2 library and what and how that works is what takes us 6 to 7 lectures to get through. So transforms you can think of as just a reversible function. The general concept of transforms is just a reversible function that helps you take data closer to what you need to model and back again to closer to what you had to begin with. Then think of pipelines as just a bunch of transforms stuck together and the composition of the transform. So what does composition mean? And as I said, there are probably people who understand this already, but essentially composition means you take the input, let's say X, pass it through the first set of transforms, the output of that to the next set of transforms, and the output of that to the third set of transforms, and so on. And a pipeline is just a sequence of such transforms strung together. And the concept of a data set then is just, again, a list of transforms or multiple pipelines operating on inputs such as images or data such as text lazily. And we'll get into more understanding of what lazily means. Basically, it means that you don't operate all at once, but you do it at the time when you need the data, and this is done in order to conserve memory. And so a data set basically applies a list of transforms or pipelines to a collection, which could be a set of parts, a set of images, a set of data, text, and so on and so forth. So that's kind of, again, Jeremy has taken 10 videos to go through and I took one slide. So by, this is definitely at the end of it, you only would have a chauffeur level understanding of what I'm talking about, but we'll take the rest of the lectures and this is just the orientation. A little more about the transforms and the pipelines. Essentially, and I say key because there are many more as you will see, but there are 3 key operations that transforms support. And first of them is setup, which basically helps you ensure that the data you receive is set up correctly before you apply the transform or the pipeline to the data. The other very key method is encodes, and basically the encode method of a transform acts on the data and moves it towards something that can be useful in a model. And in the backup of the slides, I've included a couple of examples. If you want, you can take a look at those. Again, I would encourage you not to get caught up in the details of the code right now, as much as to look at what the encode function does as a whole. There's, I think, a normalize, and I forget what the other example I included are, but the bottom line is it takes you closer to the data or the tensors that you would be using eventually as data in a model. And what the decodes does, and not all transforms have the decode, but some of them or most of them do, it helps you undo the encoding that you did and take you back in the direction towards your input that you started off with. And this is how you can kind of continue to hold the semantic that the data that you provided is an image, and therefore show it, for example, even as on the one hand you transform it in order to take it towards a tensor. Now how, and again, just unwrapping the mystery a little bit, these operations, one of the things that the encode, the setup, the decodes, they operate, and these kind of operations, they only work on certain types of data. So for example, if you have an image and you have a mask, you could potentially, and as we will see in much more detail when we go through the course, we'll see that you could make the encode only work on an image, a PIL image, or you could make the encode only work on a PIL mask. So the operations on transform and the transform infrastructure and the transform class is such, and so is the pipeline, that it helps execute code that is different depending on the data type. And for this, there is the whole process and infrastructure that Jeremy has set up in the FastAI version 2 library called type dispatch. And essentially what it does, the type dispatch mechanism, is when you call a function or a class with some argument like, say X, it actually looks at the type of X and calls the appropriate function or method. So it calls the appropriate encode function of the transform and applies it to that data based on the type of data. Similarly, in the decodes, for example, or even in the encodes methods, it has the ability to cast the result of what you're doing to a particular data type. So these are significant implementation details that Jeremy has in FastAI version 2 library that really helps make the library generic and capable of handling a whole variety of data at different levels of abstraction. Okay. Any questions so far? Do people want to take a look at it very quickly at the backup slides as to what the examples are, or should I keep going? Anyone?
Yeah. So one question would be if you could just quickly say an example of how of the encode applied to a certain specific type of data, what comes in and what comes out, and the decode.
Sure. Let's get then to, sorry to skip around, but let's go to the backup slide of where I have an example of a transform. Right. Can people see the into float tensor transform?
Yes.
Okay, so this is directly code taken from, and I'll kind of get to in a couple of slides where all this code is in the library. But here's an example of a simple integer to float transform. So what this does is it transforms an image to a float tensor and then optionally divides it by 255. And so here's, you can see that there are two encodes within the into float tensor, right? Two methods, both of them are encodes. But the key is to understand, and we'll get into how, so in the next couple of slides, but what I want to call your attention to here is the fact that the encodes of the first one is actually the data type mentioned there is tensor image, and of the second one is a tensor mask. Now, forget about the details of what it actually does, but do notice that for the tensor image, what is returned is actually a float, and for the mask, what is returned is actually a long, right? So that's where, for example, if you call the into float tensor, and if you happen to call it on a tensor image, you will get back a float. If you call it on a tensor mask, you would get back a long. And if you call it on anything else, it'll just not do anything. So any data of not the type that the transform applies on, just the transform just ignores that data. Also,
Hey,
notice,
Srinivas,
yes.
quick question. So when we send it like an unsupported type and you said that it does nothing, how is that handled cleanly in the code? I mean, is there like an error message? Or?
Those we'll get into. Okay. That'll take a lot of, I mean, there are so many, as I said, this is such a high level of abstraction that, you know, think of it this way. So yes, we will get into it in a lot more detail in what transform does, but there is so much detail there as to how to handle all the different cases of what could go wrong and what are the situations you need to handle and so on and so forth. But yes, he's paid excruciating attention to all of that in the library. We will see that as we go through. This is just an example. I wanted to get you to have an understanding of the flavor of how things work rather than the details of how they work. The details we'll get to in the next 10 lectures. So yes, the short answer is yes. We'll get into it as we move forward. The decodes, again, operates on the tensor image and returns what you would have provided as the input. So it's kind of like taking you back to what you provided as the data. So that's why I said that the transform in general conceptually is a reversible function or class. And then let's look at an example of a transform. It's the next slide. Can you folks see the example of transform bit setup?
Yes.
Okay. So here is something that we are used to, especially if you have used the library before, normalize. Interestingly, normalize is also made into a transform now. And here you can see, again, the details of why something is the class method and from stat, blah, blah, blah. There's a lot of detail to that. What do the parameters mean and the order mean? And there is a lot of meaning to all of that as well, which at this point, I urge you to ignore in the interest of just getting focusing on the key items. But the significant thing I'd point to is in the case of normalize, as I said, it includes the setups. And that's necessary because if you give a set of images to normalize and say normalize this, but if you, for example, have not provided a mean and a standard deviation of that data set, the transform is smart enough to set itself up and go through and run one batch. If that's where you see the dl.1 batch, find what the mean and the standard deviation are and use that in the encode and the decode to normalize the rest of the data. So it's an example of where setup is useful, that in setting up the data before you run the encodes and the decodes. And in this case, you can very clearly and simply understand that encodes means just subtract the mean and divide by the standard deviation and return that. And decodes means, and again, he does something a little more complicated to take it to the CPU or the GPU, but ignoring that for a minute, it essentially reverses the normalization. So it's something that in prior lectures or courses is referred to as denormalize. So you can see here why it's a reversal, or why this transform is reversible in the sense of encodes takes you from an image to a normalized set of images, and decodes of the same transform takes you from a normalized set of images back to a denormalized set of images. So does that answer with a couple of examples? There's many more transforms that you can get to look at, and a lot more complex cases of handling setups and encodes and decodes and stuff. And but again, keep in mind that all I'm trying to do here is to expose you to the concepts which would help you to understand better as you go through the details. Does that answer your question, Joseph?
Yes. Yeah.
Okay. So back to where we were. Sorry again for the jumping around. So transforms and pipelines, and to Anand's question. So how does all this happen? This is where we get into the significant modifications of Python that Jeremy and Sylvain have made in order to get all this working as they would like it to. If you have followed Jeremy in all of his courses, he's been, frustrated with how or the limitations of Python, and finally he said, okay, I'm just going to make some fundamental changes. He kind of wanted probably to do it in Swift, but realized that will take a while to get there. And so he kind of said, let me just go make the changes in Python and get it the way I would like it to be. So what he has done is implemented, as I said, the concept of type dispatch. So those of you who are Pythonistas or have used Python extensively know that in more recent versions of Python, you have the type annotations, right? So after each of the data, you can put a colon and then describe the type. This library, FastAI version 2, extensively uses type annotation. I wouldn't even say uses, it relies on type annotations. And interestingly, it relies on type annotation, not like any other Python library for type checking, but it actually relies on it. And that's why I say relies, because most of the other Python libraries, it's more to type check. But here, the library actually relies on the type annotations to make certain behaviors happen. So certain changes in what results you get occur because of type annotation. So what are a couple of key ones is you do something different. So the encode does something different depending on the type of annotation or the type of data, and therefore the type annotation of the data that you have. As we saw in the transforms, if you go back and look at the backup slide, you'll see that there are type annotations for each of the O's. Is there a question? So there are type annotations for each of the O or input data. And depending on that, the encode will do, or another way of saying it is the different encodes will be called depending on the type of the data. And similarly, depending on the type annotation you provide for the output, the function will actually cache the data in the particular type. So the behavior of the function changes based on the type annotation. That's not at all common. It's almost like making Python a typed language in a sense. But he uses the type annotation extensively in FastAI version 2 to make this kind of behavior change happen. And in order to make the behavior change happen and the infrastructure behind it, he has to go make changes in Python. Significant changes, but understandable changes. Again, as I said, I'm not an expert by any means on Python, but I could say even I was able to follow along of what are the changes that would be needed and how he goes about implementing those. There's a variety of other enhancements and simplifications, and all of them are, by all of them, I mean all of the changes to Python that he makes are found at the GitHub link that I provided. Now, the Python changes aren't the only thing that are needed to make the FastAI library work. There's also modifications to PyTorch. All that is, though, simpler than the changes in Python. So all that is included in just one notebook. That's found at the link again that I've attached. And as to the FastAI 2 library code itself, we'll talk about that in a couple of slides. Any questions so far?
Srinivas, so the details, I haven't gone through all of the videos, so I'm not aware of the content, but is there discussion on the fast code and things like that?
Yes,
okay.
Towards the end. But as with Jeremy's typical style, and I think it is the correct way also, he starts in the middle. So his first lecture is much more about, again, if you're familiar with the style of his teaching, he teaches kind of top down rather than bottom up. So in fact, the last two lectures are where he gets into the details, or the last maybe, yeah, in fact, the last two lectures are details of Python functional changes. He doesn't start at, oh, here are the meta classes that I need in order to make type dispatch work. That would, I think, just throw all of us at the deep end of the pool, and we'll be lost for a while before we can swim. So he starts somewhere in the middle about talking about transforms and how to use them and how they're applied, for example, on a pets data set and things like that, and then goes up from there, and then subsequently and finally goes down into the details. Okay, so that's a much better route through the library because it doesn't throw you, and it gives you, ability to kind of use or become familiar with the concepts and by using them, and then bit by bit get into the details of how those concepts are actually set up, right? So the Python modifications are all covered in 4 notebooks. In fact, it took me a while to find that they were actually not where the FastAI library is located, but in slightly different locations in FastCore. And I just provided a basic index to the 4 of them. So the 0.0 test, which he touches on a little bit in the very first lecture, is basically another very good practice that he does is as he codes in the cells of the notebooks, he tests what he codes with very simple tests to check that the coding is right. And very often what I would encourage you to do is to follow along and to see whether you can explain before he has the solution, whether you can predict what output you would see. And that is really, that would help you understand the various functions better. So by testing the functions as he codes them, you can really get a good understanding of what those functions and what those classes are expected to do. So the testing functions, these are the functions used to test the classes and the code, and they are all in 0.0 test. 0.1 foundation goes into meta classes, the foundational functions, certain helper classes that it creates, like L, which is a modified form of list that he uses a lot in FastAI version 2. There's a getAttr, which kind of fixes a couple of issues that he finds annoying as part of Python's get attribute or getAttr, under getAttr functions or capabilities. And then in O2 utils, he has a base of collection functions, network functions, sorting functions, other helpers. In O3, he has much of type dispatch logic, the casting logic that I talked about. And then in O4 is where a lot of the transform and pipeline and what you really need to do in order to get that capability built into the Python language that you can then use in the rest of the library. So we'll get into, or he'll get into all of these, but not in the beginning, because a lot of these will require an understanding of why we want to do it and an understanding of, you know, Python concepts, which he doesn't get into, but which are necessary in order to understand. So he doesn't take us into these things right away. He takes us into more of the library functions, the usage of them. And then as you begin to be familiar with the concepts, then he takes you into the details of why and how he's changing Python in order to be able to do what he wants to do with the language. The library code itself is located in GitHub, you know, FastAI version 2. And all I've done here is just, there's like a significant number of notebooks. And all I've done here is, again, provided a simple index to the various notebooks. I haven't listed every one of them to make sure I was able to fit all of this in a single slide. Like, for example, my second thing just says 02 to 06. There are like, there may be even more, because sometimes he resorts to labeling things A, B, C, and so on, as you'll see 7A to, or 07 to 09C. But the point I wanted to make was, you can, if you need to, and I'll post these slides with on the Slack channel once we are done. But this is just an index into the various notebooks and what they cover. And if you just scan it, you'll see that essentially the library deals with data and how to prepare data of 4 different types: vision, text, collab, and obviously tabular. And for, I haven't yet looked at it, but he also has medical related stuff included. I haven't gone through those notebooks, and people may want to poke around there, and he may cover it in future lectures. He even wanted to do future walkthroughs, because the whole 10 lectures, he primarily focused on, I would say, the data related portions, as I've already mentioned before. So this is just an index, and you can use that to go through and dive into different portions of the library as you feel the need to, or and so on. But obviously, he takes you through specific portions in the lectures. So as Joseph mentioned at the beginning, what I realized as I went through this quickly to orient myself, and I did go through each of the lectures, is what you will find if you watch the videos is, and then go back to the library code that I've just pointed to, is in many cases you'll not find things that he talks about. For example, he'll talk about a class called TFMDS, which is a transform dataset. And remember that these walkthrough lectures were delivered as he and Sylvain were in the process of developing the notebook. So they were doing it, and he was giving these lectures while developing. And in fact, you'll see in a couple of cases, he even says, even finds bug in the code and say, oh, we need to go fix that. So what has happened is, subsequent to these walkthroughs, they have found simplifications that they could implement. So you would find huge chunks of code which are completely different or eliminated, or portions of the class that you look at in the videos are different from what you will find in the notebooks. Also, the notebook names, for example, he refers to some notebook as 08, and that'll be like, 08 or pets 08, and it'll be more like 10 pets or things like that. Easy enough to figure out, but sometimes it can throw you for a loop. So what I'll try and do, if Joseph is okay with it and stuff, is at least each week I'll post a slide or two on, hey, if you watch the next week's video, here are the important relevant things to pay attention to, and here are a couple of things that have changed, so that if you, get thrown as I was when I watched the videos and went back to the library and I was like, where is TFMDS? Where is the D source that he talks about? And it's nowhere to be found. And that's because he's completely simplified the library compared to what he talked about in portions of the walkthrough. Again, I would say about 80% of the walkthroughs are still relevant, but there's like a 20-25% of it that is no longer directly relevant. I mean, most of what he talks is still applicable. It's just that it's different code. So if you go looking for that code, you won't find it.
Srinivas, I think excuse me, I think this is really terrific that you'll do this for us, to give us this weekly tips and pointers as to what part of our reading we have to be careful about and so on, because the libraries aren't updated. But anyway, I think it's great, and I'll let you continue.
Okay, thanks. And as Joseph mentioned at the very beginning, and even for me, there were significant Python related knowledge that's needed in order to go through the course. I would probably say that of all the courses of Jemis, probably excluding just the version 3 part 2, and even for that, I would put it lower than for this particular walkthroughs, you really need to be familiar with, if not, more than familiar with the Python in order to understand and actually use the library as in its full splendor. You don't need to really know all the concepts to watch the videos and follow along, but if you really want to apply and get to kind of what I was saying earlier of the Jeremy level of expertise or Max Planck level of expertise, then you would do well to also utilize the week to brush up on Python concepts. If you're an expert, then all of these things are probably already familiar to you, but as Joseph said, I'm not, and it helped me to go back and look at those things. So with that, let me just give you the tips for the first video to watch in the coming week, and a couple of Python pointers as well. So in the first walkthrough, and Joseph will take us through that next week, he talks, and in fact, I think Anant also provided a link basically of, the notebook development. So this is something that Jeremy and Sylvain, he's talked about in other forums, that notebook-based development, and there are two camps to this. There's a camp of writers like Joel Grus and stuff who believe that, oh my God, the notebooks, because you can execute them out of order and not in sequence and stuff, they don't lead to a very good practice in terms of how to develop and use the notebooks in data science. So they don't like that environment. On the other hand, there are increasingly people, and Jeremy has the whole infrastructure set up with NBDev to be able to do even your programming development in a notebook context. And the reason it's really superior, Jeremy feels, is the fact that you can include a lot of other material along with the notebooks or in the notebooks as you do software development. So it's not just the code, it's a bunch of other stuff that goes with the code that get included in the notebook, and then use the NBDev environment to translate all of that into Python modules that you can then import and use. So he talks in the beginning about NBDev. He talks about the setup of the library at that time, And again, I think today, because the library is in much better shape and is not as actively being developed as before, you could pretty much use the FastAI version 4 first part setup with Colab and stuff that Joseph had taken us through, and he can repeat that if people are interested, and use that to run the notebooks. The rest of the video, as I mentioned, he just introduces you to the basic testing concept, like what is test equals, what is test type equals, things that he uses repeatedly in the rest of the notebook to just check the code. Here is the next thing that, as an example of one of the things, it's a fairly trivial change, but in the video, he'll talk about 08 pets as the notebook he is using. And in fact, he uses, but now it's called 10 tutorial. So if you go back and if you look at, if you want to pull up, then you should pull up 10 tutorial. It may not be a one-to-one comparison, but most of the concepts follow. And then he talks about what a pet transform or a tuple transform and a bunch of other stuff that I'll leave you to look at. I mean, the intent again in these is not to give you an exhaustive list of everything that Jeremy touches on in the video, or else I'll be going through it, the same thing again, but to just point to things which are different and things to kind of pay attention to. And he goes through the encodes, decodes, and the show methods of those, again, at a high level. Each of these, there is so much depth and so much detail to cover that, for example, to understand what show does, while he introduces it to you in lecture 1, it'll take us till lecture 5 or 6 to really understand the details of how show works with decodes in a transform and in a pipeline. So there's a lot more in each lecture that he unravels the mystery of. And then the other significant one that I pointed to, and this was, a shock even to me because I wasn't actually looking at the code, shame on me, until I got very much further into watching the videos, and then finally went back to the code and I was like, what? I have all these notes about a transform DS and it's nowhere to be found in the library. So be aware that TFMDS just doesn't exist. It's all just data set. There isn't a whole lot that's different, but it's a lot simpler with just the data set than what he explains in the walkthrough. So that's kind of the tips, if you will, as you watch the first video. There's a lot more, as I said, in the video that you can enjoy, but these are kind of some of the things to pay attention to / watch out for. And a couple of concepts to kind of, if you wish to pay attention to, because Jeremy uses these so much that it's kind of incumbent on us to become familiar, or else we'll get lost very quickly, is he totally depends on pathlib and various uses of pathlib throughout the library. So I've included some links to why pathlib is better, and also and actually the Python 3 direct documentation from python.org on pathlib. And similarly, the other thing that Jeremy uses a lot of, and even today, sometimes I have to go back and think through, is the usage of star and star star, not just in star args and star star keyword args, but in order to transpose, in order to splat, in order to do a bunch of variety of things that he does, he uses them a lot. So again, a few links on what they mean and how they work, and all, especially the first link is really good, the Trey Hunter one on asterisks in Python, because it takes you through so many different uses of these two symbols that it's mind-boggling as to how useful they are and how many different contexts they can be used in. So this is just a couple of ideas that you can kind of become familiar with this week. As we go through, and if you are more ambitious than me, I've also provided a list at the end in backup of all of the various different concepts that at least I could think of. There may be others. People are welcome as they go through, and if they find others that to call out. But these are, again, not every single function, but more of the concepts from Python that he uses quite a bit. So again, apologize for rushing through, but in backup is all of the list of relevant Python concepts. And as you see, I just chose the first two to provide the links, but there's a bunch of other things like generators, properties, decorators, context managers, descriptors. And in some sense, these are also in some order of usage, not always, but so getting familiar with these concepts, if you want to be aggressive and with more of these concepts in Python, would only help you as we go through the library. I think that was the last slide. And thanks, Joseph, for giving me the opportunity to kind of go over at least what I found as I went through these very quickly, the videos, but happy to answer any other question people have at this time.
Thank you so much, Srinivas, for all the work that you put in to give us that summary. I think that it's going to be very useful to us as we go through these notebooks and videos. Can you please, I think you said you would do this, put those slides available on our Slack group so that other people can refer to them. Thank you so much. Sure. And as for those last concepts that Srinivas mentioned, all of those fancy advanced concepts in Python, don't worry about those. If you are a beginner in Python, we're going to try to go through those and discuss them for everybody so that you will also understand those concepts as needed to go through the library. So that's part of what our study groups are going to be all about, is sort of decoding all of this high-level stuff so that people can get to grips with it.
Yeah, and as you know, Joseph mentioned in the beginning, I brought it up and highlighted it as well. I think, and Joseph has said it and invited people to present. None of us are expected to already know this stuff. We are not Jamie, we weren't the developers. It's more to help each other gain a deeper understanding and answer each other's questions, and in the process, increase our ability and capabilities. So I would encourage people to definitely sign up. In fact, one of the things I've found, and the reason I went through this myself, is so that what you teach, you're forced to understand. So I think that's a very good way of, if you sign up for something, you're forced to go through it and learn it. If you have to explain it to somebody else, that forces you to come to grips with what you don't know, or to gain a better understanding of even what you know. So.
One quick question. First of all, thanks a lot, Srinivas, for the detail about this walkthrough. Just a quick question with regard to this walkthrough as far as Fastbook is concerned. Do you think there is a reference we can take from Fastbook back to a library, or is just a backend library which we need to decode ourselves as such?
I'll answer it this way, and then if I don't really answer a question, ask again or differently. But I think what you'll find is even in the first lecture, he uses this 10 pets, which actually is a notebook in the library, and then subsequently, we could use tutorials which are there as part of the library content in order to explore what he is using in the part 1 and what he'll be using in part 2 of the Fastbook. But what the Fastbook does is approach the problem from the standpoint of basic usage, which is what the part 1 did. And in part 2, he goes behind what the basic concepts are in part 1. So that's what the Fastbook does, because that's essentially, he just exposes you to the concepts of the various data types like text, image, collab. And the very last lecture of part 1, where Gautam took us through the RNNs and how the RNNs are constructed and how the AWD LSTM is built from the RNNs in order to do the language processing or classification. That's more of what he'll do, I believe, in the rest of, or at least the second part of the FastAI course. And if you've gone back and looked at his courses from the past, the version 3, for example, was slightly already different from what he did in the first two versions. In the first two versions, he essentially explained more of the details behind the first part of the course. What the walkthroughs help you to do is to really understand the library behind behind even the first part, and what you will cover in the second part as and when he does that. It's a layer below both of those, which will actually help you, as I started by saying, the most important use if you are more interested in usage and not so interested in customization, then the best use of the walkthroughs is the fact that it will help you to debug the usage of the library much better. Because if it throws up an error and you don't know where to go or how or why it's giving you an error, the knowledge of the library and the supporting functions can really quickly enable you to say, oh, this is the reason why, and I have to morph it, or I have to use the transform differently, blah, blah, blah. If on the other hand, you want to modify the library to help support or change it and by the way, this is the other thing I would say, is as soon as you start doing anything on your own, like even participating in the Kaggle group or in other groups that other people are running on NLP and stuff, as soon as you want to do anything on your own, you find that you have to modify the library and you can't use it as is. And when you do that, the first thing you wish you would know is how the library is set up, even if you didn't know all the details. And by no means are you required to know, and I'd like to echo what Joseph said, all of the Python details. It's just important to know that if you really want to understand the details down to the nuts and bolts of how things work, you can not know anything about decorators and descriptors and still use the library and even still modify the library for your purposes without understanding that level of detail. It's all abstracted out for you. So hopefully that was a long-winded answer, but hopefully I answered your question.
No, you did. Thanks very much. Yes.
Okay, well, I just want to say one more thing. I'm going to share my screen now, and I want to share the, hold on for a sec. Somehow, the meeting, let me get screen sharing going. And yeah, I want to share the schedule. Okay, so can everybody see the schedule that I'm sharing? This is the schedule for these classes. Can everybody see? Yeah, thank you. Yeah. So, so as I said before, we're not the experts. We're going to learn. We're all learning this together. And so I've got the schedule, and I've got the videos. The slots there are open and up for grabs. So if anyone wants to present any of these videos, just step in and add your name. I'll be presenting the next week one, but people are invited to step in. And this is a great way to force yourself to learn something, I find. If you put yourself on the line and say, I'm going to be there at 8 o'clock and I'm going to be ready and I'm going to explain this particular piece of material, that really concentrates your mind and forces you to learn it. So I'll invite anyone who wants to put that pressure on themselves to sign up, and you will definitely learn something out of it. And don't worry if you're not the expert. Just learn it as best you can and present it. There will be others that will be able to help you if you get stuck during your presentation. So that's what I'd like to say. And then the last part of this meeting, I want to turn this over to Anant because he had something he wanted to share with us. We have another like 15, 20 minutes to go, and I'm just going to turn the meeting over to Anant. So I'm going to stop sharing, and here's the screen for Anant to share.
Cool, thank you. All right, just let me know once this is up for you guys. I've actually never shared on Zoom before.
Okay. It's the green button at the bottom. You see it?
Yeah, I mean,
Okay.
I
Yeah.
did hit it, and I think it is
Okay.
sharing. It says it is.
Yeah.
What are we
can
supposed
see
to be seeing? Okay.
You're supposed to be seeing Jeremy's notes on FastAI coding style.
Okay.
I can see it.
Okay, cool. Thanks, Dinesh.
Okay.
Yeah, so as I was kind of getting warmed up to get going with the study group, I was looking at some of the resources that could be useful. And in fact, just 10 minutes or 15 minutes before joining, I found, I was just browsing and I found this, and I thought it's like a really good place to start to get. It's not something that is hugely technical, but it gives a good orientation as to what we might expect as we go through the walkthroughs and the study group. So I thought this would be a good place to start. And just to play on Srinivas's metaphor, I would say I'm not even at the chauffeur level. I think more, I'm picking out my shoes and my hat right now and just getting ready to drive around with this library. So it's good to know the lay of the land and what we might come up. So essentially, my aim, as I had earlier mentioned, and maybe some of the other people's, is like, getting familiar with the library enough to be able to customize, and at the same time also using this as an opportunity to get better at software engineering, programming. I mean, this is like a vastly used library and a very well-built one. So to understand some of the philosophy of where Jeremy is coming from. So this, he's speaking here about the FastAI coding style, and he essentially says that this is his ideas that he has developed over with his experience and coming from many different programming languages and styles, and what he has distilled down to what he believes to be an easy way of putting down concepts into readable code. So he says this style is particularly designed to be aligned with the needs of scientific programming and iterative experimental development, which is what Srinivas alluded to when he was speaking of NBDev, the kind of programming that you would do to kind of test on the spot and to look at the outputs on Jupyter Notebook and things like that. This is common. Everybody obviously has opinions about the way code should be written. And what Jeremy essentially says, like, now this is getting into, which I also think might be a good mini projects for our group, is to try and get to a level where we can actually make pull requests to the library. It can be as simple as documentation and can go even further into maybe some new testing functions or some new capability that we think is useful. I think that's a really good way to like get our skin in the game and actually start understanding how a library is built. So along those lines, for the steps or the suggestions that Jeremy has for contribution is, don't change existing code to reduce its compliance with this style guide. So when he says, especially don't use an automatic linter or a formatter, I actually don't know what that means. So if somebody else does, please pipe in. The second point he makes
there
is,
is,
yeah,
sorry to interrupt. So
please, yeah.
basically, I mean, and I'm sure there are more experienced Python coders who can speak up, but essentially the linting part is to remove, but the formatting part, if there are formatters like black and stuff, which kind of impose a standardized style formatting to the code you write. So for example, in Python, if you import, if you have import statements, it'll say it'll import and then it'll introduce two lines between the import statement and your main code. If you have a for loop or something and it goes over multiple lines, it'll have rules about how to show that and how best to format that. So it's those kinds of things which are for Python generally covered in this PEP8 document that Jeremy refers to as well. And there are actually programs like, at least the one I'm familiar with is Black. There are many others that you can include with your IDE environment like VS Code or or PyCharm to incorporate them, and that will ensure a certain style in your code.
Okay. Okay. Cool. Thanks, Srinivas.
Yeah. And the linter is basically just going to check your code for any obvious errors. So it's just all sorts of best practices. So it's just completely automated. You run it on some source code, and it'll tell you whether there's anything it's spotted which is not quite right and you should fix. But it's obviously going to be limited by the knowledge that's built into it. Yeah, that's just.
Cool. So yeah, I mean, that's one of the things that he asks us to keep in mind. And actually, I'm trying to understand exactly what he means when he says you don't change existing code to reduce its compliance with this style guide.
That means impose your own style on it. In other words, if you want to change the library, be cognizant of the way of the style that they're using and try to write the code in the same style.
Right. Yeah.
I think it's a clumsy way to say that, but
yeah. Okay. Because I mean, yeah, that's what we're getting towards, to be in compliance with the style that he's putting out. So yeah, that's what he's emphasizing there. Second thing he's saying is like make a certain basic attempt to make the code that we are writing to support the library or to extend the library to not be wildly different from how it already exists, which makes sense. I mean, because we want to be consistent and we don't want to be adding more complications with our supposed help that we will be doing. So then he goes into some general ideas, and also he has links to some resources on what he means by quote unquote good style. And he has a couple of resources. I'll read this part out, which is he's saying that in that particular paper, the advantages of executability and universality found in programming languages can be effectively combined in a single coherent language with the advantages offered by math notation. So I believe this kind of leans into like us being in a very unique place in programming also, where we are going to be in deep learning and we will be dealing with a lot of papers. This gets into basically the paper implementations and all of such. So it's good to have something that is easily understandable and also doesn't take away from the executability of the code. The other key area he mentions is the brevity facilitates reasoning, which is essentially speaking of shortening the lines of communication. He goes a little bit down here somewhere where he says that you want to be able to not scroll for understanding a certain section of code. You want to have all of it in one particular on your screen, so that you don't have to keep context switching. Obviously, I'll not go through reading all of this, but just wanted to give a basic introduction here. So he goes into the style guide as to what some ideas are. He into the symbol naming as to like how you want to name your symbols. One thing that I was good for me to know was like I kind of came in with the assumption that we would be very descriptive in our names for variables and such. Like for example, I came in with the understanding that I would be using something like this, like a first convolution layer, like in a fully very descriptive. But then he goes into reasons why you do want to abbreviate, and then he has an index here as to what those different abbreviations mean, like LM. Which is very commonly used, he says, is language model, and IMG for image, etc. And he asks us to keep this so as to again to keep with consistent with how things are in the places that we are referring to. And then he also speaks of like if we are going to be using a different library, like for example a PyTorch loss function, do use the standards that they are using there, again with the spirit of being consistent with the modifications. So yeah, we take a look at these naming conventions, etc. It gives us a better idea of what the code is speaking of. For example, when Srinivas was giving his example on the transform, I could look at the O that we had there in the code. There was like, oh, okay, that's an object. All right, cool. It makes things simpler and gets us closer to how or what Jeremy is looking to explain and code. And then the layout, essentially, this is what we spoke of earlier. You want to have such that he speaks of, like, where in a normal screen that's around 160 characters, and you want to be able to convey your idea of that particular mini concept within that, and you don't want to be so verbose that you're kind of jumping around. So yeah, there are some more things like this, which I believe is a good way to orient yourself by reading them and understanding what's going on. And then he also like it has like some syntactical suggestions, like avoid using vertical space when possible, because again, to the same aim that you want to be able to see everything at a glance. About trailing white space, etc. So then he goes into the algorithms and how the way FastAI is built is so that you are able to see what's the best, or what is possible. So what he's going into here is that our implementation of an algorithm from like a new paper that we have come across, we want to ensure that we are at least are able to replicate what they're doing in the paper, like we're at least as fast, accurate, and concise as other versions. And he speaks here of using a profiler to check for hotspots and optimize them. Now, I don't know what that means. Again, I'll lean on others here to pipe in. And I'm sure we'll go through it as we go through the walkthroughs. We'll understand what he is meaning about these things. Then he's speaking of something that is very important, of scaling, ensuring that we are meeting within our capacity of the machines that we run on, and also to ensure that we don't assume a certain huge capacity. He's basically denoting here like a 16 GB RAM. All of these are again practices to keep with his philosophy of like not needing big machines to be able to do this deep learning thing. More about that, and then so this is actually my first time reading all of this too, along with you guys. So then he's speaking here in the other stuff section that we can be safe in the assumption that we are using the latest versions of Python and the other key libraries like NumPy, Pandas, etc. But so this is where he's speaking of, like, in the PR, when we submit it and the docs, we do want to mention if we are going to be relying on something like very recent. Definitely don't be using something that is like a beta version or something. And then he says, avoid comments unless they're necessary to tell the reader why you're doing something. Because this, again, keeping with his philosophy of trying to let the code itself do the talking, most of the talking. Which is what he gets into here of, like, to tell them how use the symbol names and the clear expository code. Good practices generally definitely do link to the code in the PR request and PR to any paper. If we are implementing a new paper, to definitely attribute that. Yes, this is about how if we are going to be using everything in a module, use his antithetical to the PEP 8 way of doing things to do the star instead of doing separately, which is, again, his coding style, which makes sense, as we know, as we go through the course, to be able to do an import star instead of like importing specific submodules in there. Yeah, so more details as to some of the sharing responsibility, as to not being so concerned that we need to do everything for the user. Do assume that the user will be having a certain basic set of setup, And then again, he goes into the same thing of the automatic linter, and asks you to pay more attention to the code that you're writing instead of depending on like a software to do it for you. This is interesting. He's saying keep the pull request small, and definitely discuss it in the forums first before jumping onto like just the GitHub. So then the documentation aspect is essentially going largely into the how the docs are done with the notebooks themselves, again, the NVDev philosophy. He says to add a one-line doc string. This is the basic way we do things with like any function definition or class definition to give a quick summary of what that is about. And this is something that I'll go look into. It's like, it looks interesting. He speaks of a link here of a good role model that we can use for the kind of documentation style that FastAI is expecting. Some of the FAQs are going into why not use PEP8, and I think he explains this in the courses also, because of the way deep learning is. Not all of the existing syntactical practices might hold or might be even useful for our way, or rather our applications. So then he goes into some like technical stuff about like, you know, what to do if like if we are using one of those linters or formatters, like, you know, how to not let it annoy us. How to, and then here's an opinion. He's asked about like, you know, if he's worried about using a different style guide might put off new contributors, and he's basically saying not really. You know, they won't reject any pull requests. They aren't like they're not strict about rejecting it. And he just wants us to be able to be consistently useful with the way the library is developed. Yeah, so I think that's a good place to start in terms of like orienting ourselves in as someone who submits PRs to the library. I found it very useful. Thanks, Joseph, for inviting me to share. I actually read this as I was sharing, so that was cool for me too. It's a cool experience, and definitely can attest to what Joseph mentioned of us at the least paying more attention if we are put on the spot to share something, to learn something in a much deeper way. Thank you.
Thank you, Anant. That was excellent. So I like Anant's idea of getting to the point of some of us maybe trying to get to the point where we can make changes to the library or pull requests and be a participant in the library if possible. That's a great goal to have. All right. Well, we are at the end of our hour and a half.
Joseph, yeah. Just one comment. I forgot to mention this. The library. In what I've been through reminded me, it's Python 3.6 and above is what it's compliant with. So if you are on Python 3.6 or above, meaning 3.7 or 3.8, things ought to work. But anything below 3.6, I don't believe it's been tested on or will work. So just FYI to people, you do need Python 3 and it needs to be 3.6 plus.
Okay, great. So normally we've been using the Anaconda installation of Python. All of the that's what's recommended for all of the FastAI libraries and so on. So do be sure that you have a version of Python that's 3.6 or later.
One quick question with regard to the installation. Does this version of FastAI works on the laptops, or do we need a GPU like we have been doing for a collab or our GPU environment on the cloud? What's the opinion on an installation?
Well, I think that it could work on laptops, especially if you're Linux, if you have a Linux machine, but there are ways around. There are workarounds. If you don't have a GPU, you can probably still be able to run. You can probably still be able to run some of the code at least, if not most of it. I've run into problems with a Windows 10 machine with FastAI 2. It's not optimized. It's not really made for Windows, and so you can, if you want to run it on Windows, you'll expect to have a lot of problems. Especially, I found problems trying to run the NLP, natural language processing, text processing libraries that they have. So as a workaround, if you don't have a laptop that has Linux and has a GPU, I recommend going the Colab route, just running these notebooks on Colab, on Google Colab. And if you have questions about that, maybe we can deal with that next time.
Okay, thanks.